In this example, we will use elimination to solve different systems of equations. The equations in part A have fractions for coefficients. Before we attempt solving this using elimination, let's get rid of the fractions. Multiply the first equation by 2 and simplify to get 2x minus y equals minus 6. Multiply the second equation by 2 to get x plus 2y equals minus 8. We have now simplified the two equations. Let's solve this with elimination. The lowest common multiple for the x coefficients of our two equations is 2. Equation 1 already has an x coefficient of 2, so we don't need to do anything to this equation. If the second equation is multiplied by 2, its coefficient will become 2. Rewrite both of the equations after multiplying. We can eliminate the x terms by subtracting the two equations. (2x minus 2x is 0, minus y minus 4y is minus 5y, and minus 6 minus minus 16 is positive 10. Divide both sides of the resulting equation by minus 5 to get y equals minus 2. Now plug the y value of minus 2 into either equation. We'll use 2x minus y equals minus 6 for this example. Plugging in minus 2 for y gives 2x minus minus 2 equals minus 6. The double negatives become a positive, so we get 2x plus 2 equals minus 6. Bring the 2 over to the right side to get 2x equals minus 8. Divide both sides by 2 to get x equals minus 4. The point of intersection for this system occurs at minus 4, minus 2. In part B, we'll use elimination to solve another system of equations. First, clean up each equation. The first equation can be reduced since each coefficient is a multiple of 2. Dividing both sides by 2 yields 3x plus 2y equals 7. The second equation has fractions. Multiply both sides by 3 to get 3x plus 2y equals 7. Now we can use elimination to solve for the variables. Stack the two simplified equations. When we try to subtract, we encounter a problem. Everything vanishes. This occurs because the two equations represent exactly the same line. There are infinite solutions to this system. In part C, we'll solve another system of equations. We'll get rid of the fractions in the first equation by multiplying both sides by 2. The second equation is already in simplest form, so we don't need to do any work on this. Now we'll use elimination to solve for the variables. Stack the two equations. Subtracting the equations gives 0 equals 3. Whenever two equations have the same coefficients, but different constants, they are parallel lines. There is no point of intersection.